Yes, good morning, everybody. Good morning, ladies and gentlemen. Thank you so much for being here. Let me begin by giving you a warm welcome to the webinar of the implementation of machine learning and Internet of Things Part 1. Our current speaker it will be Dr. Eng Ganjar Alfian, and I, as a moderator, Erlangga Hermawan. Uh, our agenda for this webinar will be the opening speech from the Dean of Gajah Mada University Vocational School by Dr. Ing Agus Mariono. And then it will be followed by implementation of machine learning and Internet of Things by Dr. Eng Ganjar Alfian. After the speech of the implementation of machine learning, there's going to be discussion, and it will be closer and conclusions. So the stage is yours, Dr. Agus Mariono.
Okay, thank you very much. Can you hear me? Assalamualaikum warahmatullahi wabarakatuh. Should I speak English or I can speak bahasa Indonesia? Pak Moderator, apakah kita harus bahasa Inggris atau bahasa Indonesia?
Dipersilahkan untuk bahasa Indonesia ataupun bahasa Inggris bisa, Pak.
Oh ya, oke. Saya kira ini internasional. Ini bukan gabungan dari internasional kita.
Iya, ini yang bagian dari internasional juga, Pak.
Oke, ya, itu saya. Oke, thank you very much. First of all, thank you for inviting me to open this very important workshop or webinar about Internet of Things. We start our future in the Sekolah Vokasi Vocational College. We start our future here. And I think it's very nice because Internet of Things is already start, but it will be bigger and bigger. The need of Internet of Things. I think in the near future, in 5 years or 10 years, it will be very boom in Internet of Things, using for several things. Internet of Things actually, according to my opinion, is born in industrial era 4.0, and then after that we heard also before COVID that Japan already proposed the Society 5.0. And Society 5.0 is society supported by Internet of Things. Society 4.5.0 is a society that a very effective society, neglecting everything that very difficult, full support by internet, full support by sensor, full support by frequency, wireless system sensor, and so on. This is what the Japan people think about Society 5.0. Maybe it's very important using internet, using a gadget and so on for supporting our life. Yeah. And actually, in my opinion, we cannot avoid from Internet of Things in the future because people are going to search everything effective, efficient, cheap, and not only one element to one bilateral element, but multilateral element connected with as much as possible by sensor, by radio frequency identification, by wireless, by sensor network, and for the whole object that be connected. It will be help people in accelerating the result of everything. Yeah. It's not only for building, for electrical engineering, but for the whole life of human being in the world. Yeah. For example, for health. So nowadays, the Internet of Things for health is developed very fast. Yeah. You have already watch, and it can also can connect it with computer. You have already glass connected with internet and computer. You have already all gadget and so on connected with computing also CCTV everywhere connected with computer and so on, and traffic and also everything, building and so on and so on. So I think um, the seminar today, the web seminar today is very important for us, and we would like not only one time internal webinar or seminar about Internet of Things. We will continue. It's not only in TEDI, but I think it's also needed in like this seminar in another department. For example, Department of Civil Engineering, Department of Geographical Kebumian, Department of Likas, Department of Mechanical Engineering, and so on and so on. I think they are needed. They need about that, and I hope that we can also invite it, all department to understand to use the benefit of Internet of Things. Last but not least, I do thanks to Mr. Ganjar, who has time for us to discuss with us about Internet of Things. And I do thank also to Mr. Rashid, Norman Rashid, the head of Department of Study, who already set up this very nice webinar, and also the organizing committee who proposed and who already worked hard to realize this seminar. Thank you very much. And let's be open the seminar with basmalah. Bismillahirrahmanirrahim. Thank you very much. I give back to the moderator. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the opening speech, Dr. Agus Mariono. And we are going to go to the next session, which is our main discussion for today, which is the implementation of machine learning and Internet of Things by Dr. Ganjar Sastrawijaya. But before that, we would like to introduce that Dr. Ganjar Alfian is from Indonesia, currently live in Gwangjin-gu, Seoul, Republic of Korea. His formal education was in Universitas Islam Negeri Sunan Kalijaga, Yogyakarta, and then his master and his doctorate degree in industrial and system engineering in Dongguk University, Seoul, Korea. From 2014 and 2016, he was a research assistant in Dongguk University, and then from the March 2016 until August 2016, he was postdoctoral researcher, and then he was also a visiting researcher in 2017 in Medical University of Ostrava, Czech Republic, and from September 2016 until now, he is an assistant professor in Nano Information Technology Academy in Dongguk University, Seoul, Korea. He also received some awards. In 2009, he was received as a best graduate in UN Sunan Kalijaga, and he also received a scholarship for master in Dongguk University, as well scholarship for PhD in Dongguk University. And he also received a Best Paper Award ICST 2019 by Universitas Gadjah Mada. Please welcome our speaker, Dr. Ganjar Alfian.
Right. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
First of all, I would like to thanks to Sekolah Vokasi Universitas Gadjah Mada for giving me the chance to present some of my research related with Internet of Things and also machine learning. And secondly, I would like also thank to Mr. Dean, Professor Agus Mariono, for giving introduction related with Internet of Things. And he also mentioned that recently this technology is emerging and it can be applied in everywhere. And also I would like to thank to Mr. Aylan Hermawan for giving me introduction about myself. Thank you very much. So I would like to share about the material that today. So everyone, can you see my slide? Yeah.
Okay.
Right. So the title today is about implementation of machine learning in IoT industry. I will give you two example application. This is related with my research that I have done in several past year, and this research is utilize a machine learning model and Internet of Things. So, as mentioned by Mr. Erlangga, that I'm working in Nano Information Technology Academy, Tonggu University, Seoul. So, this is private university located in Seoul, center of Korea. Okay, so the content of my presentation today first will be introduction of IoT and machine learning, and second will be application of food traceability system. So how this IoT and machine learning can be applied for food traceability system? How this IoT and machine learning can be utilized to make sure that the food safety and food quality can be guaranteed. And the third one would be application for healthcare monitoring system. How we can utilize this IoT technology and machine learning to improve the health quality for user or for patient. And lastly would be conclusion and future work. So I will start first with the introduction of IoT and machine learning. Uh, this is very general concept and is already mentioned by Professor Agus Mariano that Internet of Things is related with thing that connected through Internet. Okay? So anything, it can be the device which previously is not connected to Internet, and if that device is connected to Internet, then it follows the concept of IoT. And the focus of IoT is configuration and controlling networking that previously is not associated with Internet. And this type of new revolution, because we can gather the data, we can, by installing some sensor, we can get the sensor data, and then we can, what you can say, analyze and visualize for some application. So I give you this example. This picture is application, for example, RFID. RFID is radio frequency identification. This technology can be utilized to track the movements of, for example, object, product in supply chains. And another one, for example, for cold chain, we can utilize some sensor, for example, Raspberry Pi or another sensor, and we can gather the temperature and humidity of the product. And those device is connected to Internet. One is connected to Internet, the data can be gathered and then can be utilized for another application. This is also another concept in Internet of Things. In Internet of Things is not limited just connecting device, but it's also communicate and exchange the data. As I mentioned before, it is not just connected, but how we can gather the data from different location, and how we can control this device, and how we process this data. Because one this device is connected each other, we can imagine there will be a lot of huge data and a lot of different format of the data. Now the next question is that how we visualize, how we analyze for another purpose. And in this picture, as you can see, I give you an example of application in healthcare. You see nowadays there are a lot of smart watch, this kind of health device, for example, to get the information of heart rate, blood pressure, weight, and so on. Those devices can be connected, for example, through the Bluetooth Low Energy, through the smartphone, and then after that can be gathered in the server side and can be analyzed, for example, for classification or for prediction for healthcare service. So I will talk this two subject, two case study later in detail. Okay, the first one is I mentioned about the Internet of Things, and the second part it is related with machine learning. This is a branch of artificial intelligence, and it is focused more development of algorithm that learn from the previous data. So the machine learning is type of concept where we focus on developing some algorithm and how this algorithm can learn from from the data, from the past data, and give some prediction for the future. Okay, so in this picture I give you these two examples. The first one is that first data gathering is very important in machine learning. When we gather the data, we have to make sure this data is clean. Okay, this data can be utilized for the future, and after that, we need to find some specific model or some specific algorithm that can be utilized to learn from the data. When this learning process is complete, whenever we have a new data, we can give this model, this train model can be utilized to give some prediction or some result of classifications, results of analysis, something like that. So that's the concept of machine learning. The key of machine learning here is the data. If we don't have data, we cannot learn. Okay, so there are a lot of types. It's this concept of machine learning. Supervised, unsupervised, semi-supervised, and reinforcement learning. So the key here is that if we have label data, if we have outcome or class, we call it supervised. If we don't have class or we don't have outcome, we call it unsupervised learning. If we have some class has label, some not, then we call it semi-supervised. And reinforcement learning is by giving the reward. We train the model. If the model gives good prediction, we give the reward. If the model gives wrong prediction, we give some kind of punishment. Right? So that's the cluster, the group of machine learning. This one is also very important stage in machine learning. If we do research in machine learning, at least we will follow this step. The first one is data preprocessing. So in this data preprocessing stage, first we need to gather the data. When we gather the data cleaning must be conducted. For example, as we know, in the real case, the data is not always perfect, right? So the scientists, the data scientists here is need to make sure that the data is good enough to be used for analysis. So the process of filling the missing value, removing outlier is the process that must be conducted first for machine learning. After that, in the train model, we need to find some algorithm, to learn from this data set. So in this train model, selecting algorithm is very important, and also selecting the feature, the attribute that can be utilized for learning and prediction is also important. And after that, in the third one, will be evaluate the model. We need to perform the evaluation of our train model. When we learn from the data, we got the train model, right? Now we need to evaluate how good our model is. So in this step, we need to evaluate this model by using, for example, accuracy and another metrics. And also we need to compare with another algorithm. So the third step is very important. And the last step, I believe also most important is the deploying the model deployment. When we generate this smart model or train model, we need to make it online or can be utilized for real-time demonstration. So I believe, for example, in Sekolah Vokasi, you guys focus more in practice, right? So it's not only theory, and it's mean when we develop the machine learning algorithm, we not only focus on selecting the best algorithm, but also we need to make sure that this algorithm can be implemented in real case. Whenever we have a new data, it can be used for classification, for example. So this is the last step in machine learning. We call it the model deployment. Right. So now I give you two examples of application IoT and machine learning that I have done in as part of my research. The first one is application for food traceability system. So why this is important? It is related to food safety. Okay, so everyone, the customer, uh, the customer is aware with the food safety, food quality, and it's gained a lot of attention from the customer. The customer need good quality product. Okay, and one of the solution is that we can implement what is called a tracking and tracing system. Right. So by monitoring the movement of the product, by understanding environment information of the product, at least we can give guarantee to the customer that this product is good. So one of the application RFID. RFID is radio frequency identification. We can track the product, right? And also another IoT device. Some of the IoT device it can provide functionality such as monitoring the temperature, humidity. This two information is very important for food product, especially for perishable food. Okay, for a cold type food. Now, this is introduction about RFID. I believe some of you already learn about this concept, this type of technology. It is auto identification technology, and it can be used to automatically track and monitor the product, the object. Okay, so the key here is automatically track with the long distance. If we compare, for example, RFID technology with the barcode, okay, in the barcode scanner, we need to get very short distance, like some centimeter. But in RFID, if you use ultra high frequency RFID, the distance doesn't matter. It can be like 10 meters. Okay, so it can be detect the product like 100 at the same time, very fast. And it is good application for the supply chains, logistics, and so on. There are so many applications. Here, at least there is a part that we need to consider in RFID. First one is a tag. This tag must be attached into product. It can be passive, it can be active. Also, we have an antenna. Also, we have a reader and connected to computer. And this second picture is that the person using handheld reader, this small size RFID reader, you can read, the object in the little closer distance. And the third one here, we have a picture of forklift. The forklift moving the product through the kit, RFID kit. So whenever the product is moving through this kit, the information of the product can be recorded automatically, right? Now, this is a real example in Korea. Maybe some of you already heard what is the kimchi. Kimchi is traditional Korean food. In Indonesia, it's almost similar like the kerupuk. Almost everyone is eating. For example, in Indonesia, we eat kerupuk or tempe every day. Right? In Korea, kimchi is side dish. Side dish is very famous. Fermented food is made from cabbage.
Itu namanya rujak, Pak Ganjar. Bisa rujak.
Ya Pak, benar sekali. Rasanya hampir sama, cuman bedanya it's a little bit more salty ya. Right. Okay, now I have a chance to visit the kimchi industry. We try to implement this technology RFID for kimchi industry. So in this picture, the last part of this picture, we have different supply chains. We have producer, transporter, distributor, transporter, and the last one is customer. So this is the most, what you can say, most well-known, the supply chain for food. Usually for food, it's very short. So the producer, they produce the kimchi. After that, they move it to the some cold storage, and after that, they move it to the truck, and after that, distributor, and they deliver to customer. So this is the product flow. Now, how we can provide this IoT technology for kimchi industry, IoT and also machine learning for kimchi industry. So this I took from my the paper. This published in this journal. You can find it. You can see the detail of our study. Anyway. First of all, we can install the RFID in different places, in different supply chains. And after that, all of the data must be sent to the web service, to the server side, and then it will be stored in some database, and after that we will present to the to the management or to the customer. And here the key is traceability system. So our traceability system, it will track the movement of product, because whenever all of the product must be attached with the tag, RFID tag, right? So whenever the product moving through the RFID reader, it will be automatically recorded in the database, right? And the second one is that we utilize the IoT sensor, for example, Raspberry Pi. We install in the cold storage distribution or in truck, so we can record, we can gather the temperature and humidity in very short interval, for example, 1 minute or less than 1 minute. And the second one is the tag direction module here. This is our purpose. We try to improve, the accuracy of detection by presenting tag direction module. I'll explain later. Now, this is the application in industry. First is from production line going to different supply chain, truck, and so on. So in kimchi, they move from production line to customer, and the temperature is very important. Temperature is very important key, because we have to make sure that the temperature must be less than 10 degree, 10 degrees Celsius. We pack the kimchi, we put it in the special box, we attach with the tag, and this is example of RFID reader. We can use the fixed reader, which is very big type of reader, ultra high frequency, and also we can use the handheld reader, which is short distance. This handheld reader, it will be utilized by the truck driver, right? And RFID reader will be installed in the warehouse or cold storage. Right, this one is the application. For example, we have tag attachment, we put the tag, and then whenever the forklift moving the product through the, you can see here antenna, all of the product will be recorded automatically. This one is, for example, application of the truck driver scanning the tag manually, and after arrive to the customer also scan product. For example, the product is arrived and so on. For the server side, we can see here some visualization. We can have information of the product, how many product will be recorded in some certain location, and also we can see if we present it in terms of map, we can see the nice visualization. The product is moving from one part to another part. Right. I mentioned also another one that temperature and humidity is very important here. So one of application we can use, for example, Raspberry Pi with the THT22 sensor. This one is to record the temperature and humidity. You can program the Python inside there. You can record, for example, the temperature and humidity frequently and send it to the server side. So this is one of visualization in the server side. For example, if you record it every minute, then you can present it in terms of graph. Now we have a problem here in RFID kit. The first problem here is that this technology read the product, large amount of the product simultaneously. So the problem is that because it's reading with the high frequency, and also reading the distance is so huge, so wide, that sometimes it can read the noise, the noise data, because here reader cannot distinguish the direction. Okay, that was the first problem. And second problem is that, try to imagine in this picture, we have a cake, the product is moving inside, or after that the opposite direction, maybe moving outside. The problem with RFID here, reader, they cannot distinguish, they cannot differentiate whether the product is moving inside or moving outside, right? This is the second problem. The first problem, there are some noise data, and the third one is that, if we have metal object in that area, the signal is reflected by this metal object. So the distance is getting longer and far away. So that's why we have so many noise here. Method to detect this direction and movings, for example, signal strength, timestamp, and so on. Now we try to find some literature from previous study. I try to probe in terms of tag movement, whether the tag is moving or static. There are so many previous studies. You can see here this tag is moving, this tag is static. And in terms of the direction, also there are so many previous studies. We need to find whether the product is going inside and going outside. Now our purpose model here is our purpose solution is we try to integrate the previous and try to solve all of the previous problem into single framework, and we will use some LSS, 1 liter with 2 antenna, and so on. Okay, I'm sorry. If you want to see the detail of the result, you can find in this in my published paper here. This research is already published in conference, by the way. Now, this methodology, to solve this problem, first of all, we need to do the data gathering process. We don't, as I mentioned before in machine learning, if we don't have data, we cannot do anything, right? So, when we gather the data, we need to find what type of feature extraction that we will use, right? And after that, what type of algorithm that we can utilize for learning and prediction. And the last part is that we need to evaluate how good our program is, how good our model is. And the next one is the data gathering. I do the data gathering process by myself. I do it inside the experimental lab. Okay, it's not in the real factory or real warehouse, but it is inside the lab. So I do many combination of the movement, and all is recorded by the reader, by the program. And when I record every movement, I give the label, and then we will ready for the next step, which is analysis, learning, and prediction. Now, we have a pattern of the different, movement. For example, the first picture is moving, move out, and if the product is moving close to the reader, we have some pattern. If the product is static, which is not moving, we have some pattern. And we give the label for every movement, and we gather the data. Now, feature extraction, we are talking about time series data here. It's not, it's not tabular data set where you already have the attribute. We're talking about time series data set. Our data is time, right? Time, the x-axis is time, the y1 is signal strength. So we need to find some feature, extraction here. So I use, for example, minimum, maximum, it's just, standard statistical, feature. Next, I use the algorithm. It's called random forest. I guess some of you familiar with random forest. It is ensemble method. Basically, it's collection of the simple tree prediction. Okay, and there is some randomization. For example, bootstrapping the data record, and also select using some sample or subset of attribute. And there is some metric that we can evaluate. For example, accuracy, precision, recall, and so on. So, okay, if you focus machine learning, application of machine learning, or research in machine learning, you can use Python, for example. In Python, they provide the library, for example, scikit-learn, you can utilize. Now, we do the comparison, for example, with different methodology, different algorithm. For example, neural network, which is regression, k-nearest neighbor, decision tree, naive, and our proposed model is based on the random forest. And fortunately, our model, provide the highest accuracy here. And here, because we integrating two different type of features, so we evaluate. So the conclusion is that if we use many type of feature, then accuracy is higher. You can find the detail of my study here, our previous study here in this link. Right. The first example here, I'm sorry, I'm quite a little bit faster to explain because I think we have time constraint here, time limitation for presentation. So the second example here is the application of IoT and machine learning. IoT and machine learning for healthcare. So for healthcare application. Now, in this example, I will present two type of disease. The first one is diabetes and hypertension. So diabetes, okay, and Diabetes, we have two type of diabetes. Oh, at least three types. First one is type 1, type 2, and gestational. So gestational is diabetes during pregnancy. So for a pregnancy woman, usually they have high blood glucose. And this is a very dangerous situation, diabetes, because it can create another disease. It's called cardiovascular disease, for example, stroke, hypertension. And there is a two condition in diabetes. The first one is we call it hyperglycemia, which is high blood glucose, where the blood glucose is more higher than 180 milligram per deciliter, and it can create several complications. As opposite, we have a hypoglycemia where the blood glucose is lower than 70 milligram per deciliter, and it also creates some problem here. So the key for diabetes here is maintaining the blood glucose, right? So how we maintain the blood glucose in the normal condition. So that is the key for diabetes patient. Now we have monitoring device. Nowadays, there are well-developed, device, the IoT device. The first one here is for glucose monitoring. This glucose monitoring use the blood sample. Okay, so first you picking your blood sample, and then this device they can measure how much your blood glucose. The second one here we call it continuous glucose monitoring sensor. This CGM sensor is more advanced technology rather than the first one, rather than the SMPG portable device. Okay, this one is more advanced rather than this one, because in this technology they don't use the blood for sample. Okay, they don't use blood sample, but they just attach on the tissue of skin. Okay, so like this you can see they attach the device, the sensor, on the skin of the stomach of the patient. Okay, only attaching like that, and the sensor will measure approximately the blood glucose. Of course, the accuracy for the CGM is not as accurate as compared to the first one here, SMPG. Another device we have for blood pressure. For example, here in the blood pressure, for example, in the wrist or in the upper arm. This is for upper arm, this one is for wrist. And also we have another device, for example, here, smartwatch. The smartwatch can detect the heart rate. We have the weight, weight sensor here, weight monitor. And those devices has capability to connect through, for example, Bluetooth low energy. So if we can, we can give the command through our smartphone, because our smartphone nowadays they have Bluetooth low energy, right? So it can be connected. This smart device can be connected through smartphone, and then we can gather the data automatically. Next, this is the proposed model that we already developed. For the detail, you can find in the source. It is already published in 2018. So we use this type of sensor for the patient, and after that we gather through a smartphone using Bluetooth low energy, and then the smartphone send the data through the internet, and then it will be stored in our server side. And in our server side, we will have two modules here. The first one is the forecasting blood glucose and classification. I will focus only for forecasting. Forecasting is like predicting the future blood glucose. Okay, so before I mentioned to you that for diabetes patient, it is very important to manage the normal blood glucose, right? If we have some system to give the future prediction, it will be beneficial for the patient, right? Because the patient, when they know the information in the future, then when they know the future information of blood glucose, they can at least give a warning. So the patient will more take care of themselves. Okay, so diabetes here is a matter of managing the blood glucose. Because for diabetes patient, if they eat a lot of glucose, food, for example, ice and so on, their blood glucose is getting higher, which is bad. Right? So the future prediction, future value of blood glucose is very important for the diabetes case. Okay, here is some application. I believe some of you here is coming from Sekolah Vokasi, where the application is very the practice is very important in your cases. So we already tried, and it is possible to connect you through our smartphone. We can develop some application, Android app. We can use the concept, for example, GATT. This is concept generic app to communicate between the client and server, and we can gather one together. We can send the data to the server. Now, I was talking about forecasting the blood glucose, how we can predict the blood glucose. This type of research is already done, in the last couple of decades. I think, yeah, last couple of years. So many previous researchers already, developed this algorithm for prediction, and we try to propose different feature extraction here by combining the sliding window with the statistical feature, and also we try to propose some different type of algorithm which is called XGBoost, extreme gradient boosting. And our purpose here is try to predict the next 30 minutes and next 60 minutes of blood glucose. Okay, so for example, now I have a current blood glucose, and the purpose of our model is to predict the next 30 minutes and next 60 minutes of my blood glucose. So that is the key. Okay, that is the purpose. It is very important if we are working in medical area. We need to gather the data set, and unfortunately, this data set is very difficult to gather because we need to get consent from the patient. We need to follow some standard from, for example, from hospital. There is a lot of steps that we have to conduct. But the thing is that we can find the public data set. Okay, so I use the public data set from the DirectNet. You can find in this link. This data set provides you the information of blood glucose measurement every 5 minutes using CGM. Right? So it's for type 1 diabetes patient. So if you go to that link, to that URL, you will find the data of diabetes patient. It's include the information of the blood glucose, which is collected every 5 minutes or every 1 minute. Now this is okay. If we have time series data set, we call it, this one is time series. The most difficult part here is how we extract the feature. Okay, so to extract the feature, I use the last previous value. For example, here I use last 30-minute value data, and then each 6 minutes is to predict the next 30 minutes. Because the data is collected every 5 minutes, so 6 multiplied by 5 is 30 minutes. So we need to prepare the data in this format. Okay, and then we present into matrix, input matrix, and the last one we have the output vector. Now we add additional feature beside the last 30 minutes. So we add here the statistical information, for example, minimum, maximum, median, and so on. Okay, so we add this feature with assumption that the accuracy will be higher. Now we have XGBoost. XGBoost is also type of ensemble learning model, the collection of small tree. The difference as compared to random forest is that when we generate the new model will learn from the previous tree. Okay, so that is the key of XGBoost. We can use Python, for example, for implementation, scikit-learn. We split the data into 50 training, 50 testing. And we use evaluation, for example, RMSE, R, and mean average mapping. Okay, sorry. Now we compare this data set, okay, with different methods, and we got here, for example, if we have low RMSE, it's mean better. So our model present, the best result here. R, if we have highest R, it shows the good prediction, and we have low MAPE, we also have a good prediction. So our model, for example, B, to predict the next 30 minutes is the best one. And for predicting the next 60 minutes, it's also provide the good result. Okay. Now, this is the example. If we plot, because our case is time series data set, if we plot for the case of patient ID 22, here is the blood glucose value, which is collected every 5 minutes. And this one, the y-axis is blood glucose with the metric is mg per kl milligram, and this one is to predict the 30 minutes. You can see if our model for predicting 30 minutes, it's quite close to the real data. But if we have, more longer prediction horizon, which is 60 minutes, our accuracy is not that high as compared to 30 minutes. It is normal, actually, it's normal. Now, this is the impact of feature selection. Most of them, if you use additional statistical feature, it will produce low LMSE, most of them. Right, so I think this is almost the last part. I mentioned for machine learning, we have so many steps, right? The first one is that data gathering, and after that, preprocessing, training, evaluation, and the last part is the deployment, model deployment. So in the model deployment, if you're interested in this research, you can use, for example, Python programming language. If you're familiar with Python, you can use several libraries, which is I suggest to you. The first one is Joblib. This Joblib is provide utility to saving the model of Python, okay? And the next one is a Flask. This Flask is like web framework, micro web framework. You can develop the API, you can develop web application using Flask through Python. Okay, so in this one, in the next slide here, you can see this is one of my current project. We can develop web-based application using Python. We combine Python, Flask, and for example, web programming language, for example, PHP. We can develop this one. So this result is the result from Python. We can present it in terms of web-based programming. Why this is important? Because when we have the model, we have to make sure that this model can be used for broader purpose, for the general purpose. So that's why we need to make this type of web application system. Right, now this is the last part. I will go for conclusion and future work. In conclusion, I will conclude from my two experience here. We can we can integrate machine learning with Internet of Things, and it can, provide the higher productivity. It can provide, good decision making and so on. And if we apply for traceability system, for example, for food, okay, it can improve, food quality and safety, okay. Safety means because we're tracking the product, right? So we know the product will move to this location, to that location, and so on. So it will give, relief to the customer that this product is safe enough. And the last one, if we apply for healthcare service, it can improve the healthcare, service for a patient. Of course, there is a limitation in the future work that we will tackle. The first one is that we need complex data set. Why? Because in machine learning, it's very important. If we have small data set and our data set is not, it's not complex enough, it is not good for algorithm to learn and to give a prediction. So we need the huge amount of data and complex enough. So when we have the data, we can use some algorithm. The next one is that if we deploy our model in real case, in real application, how we handle the fast incoming data. So it is a matter of the big data, how we handle if we have so many access and so on. And we also need to employ the different machine learning model, right? So I think that is the last part. Oh yeah, this is just additional information. I think maybe some of you, for example, is working in some research and you need to publish some paper, you need to publish in some journal, special issue. Me and my colleagues now is opening the special issue in the sustainability journal. It is Scopus and SCIE journal, which 2.5 impact factor. So we welcome you if you want to submit your paper or journal in our special issue. But unfortunately, this the journal is not free. It is open access and it's quite expensive. Anyway, you can access the detail in these following links. Right. So thank you very much for your attention. I hope my presentation here gives you some, overview how we can apply the Internet of Things and machine learning in different application. I hope it will give you some benefit so that you can have, different application, for example, IoT in different area. So thank you very much again. Thank you very much for your attention, and I will give back again to moderator, Mr. Elanga. So the time is yours. Thank you.
Okay. Thank you, Mr. Ganjar. This concludes our previous session, and then we will go to the following session, which is the question and answers. So the ground rules for the question and answers is first the attendants must write it on chat first. After the attendants write on chat, and then we will call the name of the questioners. And also after you have the opportunity to ask, please also introduce yourself. Please tell your name, which institution that you will belong to. Okay, so our first questioner is Mr. Sigit Prasetya. Are you there, Mr. Sigit Prasetya? Hello.
Yes.
Okay. Please introduce yourself.
This should be speaking English or can be bahasa ya?
You can also speak bahasa.
Okay, because my bahasa is better than English. So Pak Ganjar, salam kenal, sehat selalu. Pertama dari staging machine learning tadi yang disampaikan Pak Ganjar sangat baik sekali. Bisa kembali ke slide 1 Pak, yang pertama dari staging machine learning. Nah ini buat teman-teman students ya, yang saya ingin cermati dari sini adalah kalau kita buat machine learning sederhana lah ya, seperti yang dibuat Google Cam 2 tahun lalu ya, membedakan antara kucing dan anjing gitu ya dari setiap foto yang diberikan. Nah kira-kira dari tahapan ini berapa lama kita buat machine learning untuk yang sederhana seperti itu. Kemudian dari tahapan ini yang paling sulit di mana Pak? Itu saja Pak Ganjar, terima kasih.
Okay, Mr. Git, where are you? Which institution that you belong to?
Saat ini saya berafiliasi di Asosiasi Profesi Masyarakat Transportasi Indonesia (MTI).
Okay, thank you. Okay, will you answer this right now, or we have to like make it a batch, Mr. Ganjar? Which one do you prefer?
Up to you. I can answer right away. In Bahasa, I think it's much better.
Okay, I think if you're as a speaker, probably you can answer it in English because there are some people which has yeah. Okay.
Sorry. Okay, I will answer this now.
Yes.
Okay. The question from Mr. Sigit is very interesting question, and it's happened to every data scientist. And the first question is how long it takes to prepare to develop this machine learning model and ready for the deployment, for example. Okay, that's the first question. Well, honestly, it's depends, sir. I mean, it's depend how complex your problem is. Okay, if we only focus for the toy problem, which is just project for in the class, simple problem, then you can develop it. It's very fast, less than 1 day. If you are already familiar with, machine learning algorithm and some application in Python, it can be like that. But if our problem is very complex enough, for example, Mr. Sigit is coming from Association Masyarakat Transportasi, right? For example, in terms of gathering data, for example, from logistics, we need to gather the real data, right? Real data from logistics. It will take time for the first step only. With gathering real data, we have to make sure that our data is complex enough. That is the first problem. It will take time if our focus is to make it real application that can be deployed in real case, not only toys problem. Okay, so it will take time. And second thing is that we need also to train the model, and for selecting this algorithm. This part is also take time because if we don't have much background about the algorithm, then how we can select that this algorithm is better than this one? Okay, so to get the some solution, first of all is that we need to read many literature. Okay, we need to read many previous study. Usually in this area, usually in this type of data, what kind of algorithm is suitable? Okay, for example, for time series, this data is suitable. For the image data set, for example, CNN is provide the highest accuracy and so on. So we need to educate ourselves to find the best algorithm. And the last one is deploying the model. Also, it will take time. So my short answer is that depend on your case. If you have a small case, then you can do it very fast. If you have very complex problem, then it will take time. And which part is which stage that provide the most highest difficulties? Well, honestly, is that I think developing the algorithm it will take time because when we selecting the algorithm, we need to understand first our data set. Okay, we need to make sure that our data set is good enough. And selecting algorithm is not just using algorithm, not like that. So we have to, as I mentioned before, we need to read from the literature, we need from previous study what type of algorithm that's suitable for this case. So, and if our purpose, for example, and if our purpose is to improve the accuracy or to compare with the previous study, that is most the hardest part because we have to also, once we when we learn and give the prediction by using our algorithm, we need to compare with another algorithm. So I believe the model development, algorithm development is most difficult part. Thank you. I hope my answer satisfy your question.
Short question, Pak Ganjar. What is the parameter to select the best algorithm?
Oh, parameter. Kalau bisa, what is your for example case study? What type of data, for example?
Make it simple lah. Just kucing and anjing.
Okay. Yeah, we are talking about. Yeah, then we're talking about image preprocessing, right? So in image, the first problem is that feature extraction. You cannot use the pixel as it is, right? We need to find the feature that can be utilized by the algorithm. So nowadays, I think for the image is the deep neural network algorithm is most well known, and it's until right now it's provide the highest accuracy, like the CNN. And there are so many models of convolutional neural network which has provided the highest accuracy. But the problem here is that if we have a huge amount of data, it will take time to learn. You need the very high specification of computer to do that. So yeah, I think for the case of image, you can focus on the deep learning algorithm, for example, CNN. Thank you.
Thank you so much, Pak Ganjar.
Yeah. You're welcome, Pak. Okay, Mr. Ayangga.
Okay. Then our next question is from Mr. Kevin Kautsar. Hello, Mr. Kevin.
Hello, yes. Thank you for the time.
Thank you.
Good afternoon,
Good afternoon.
Mr. Ganjar. I'm Kevin Kautsar from the Internet Engineering student of Universitas Gajah Mada.
Yeah.
I want to ask about the smart health sensors that was in the IoT section about the sensors reliability when we bought it from the market, and is it approved by the medical community for daily usage and development as an individually new device?
Okay. already approved, right? Okay, let me find the example. Okay, yeah, this part, right? Thank you. Okay, Mr. Alanga, should I answer right away?
Yes, please answer the questions right away.
Yeah. Okay, so the question from Kevin, from Mr. Kevin from Internet Engineering, the question is that the IoT device that I present or some the well-developed IoT device, is it already approved for by the medical institution, for example, right? So okay, I give you this in the slide. You can see right in this slide. The first picture is that this product is named CareSense or Accu-Check. This one is the portable device to what you can say to measure the blood glucose, and this device is already approved by, for example, uh, ADA is Association Diabetes American Diabetes Association, I think, yeah, and it has been used for many research and for the medical purpose. And second one here is that I forget to put it the name, but for the CGM sensor here, okay, CGM sensor is also is already approved, but for application of CGM sensor, they must be accompanied. It must be what you can say used together by the blood glucose measure. This one, the first one. Okay, so for the first one, it can be standalone, and it's already approved. But for the purpose of second device, this one CGM, the suggestion from the medical doctor is that you have to use together with this first device, because in the second device actually they're not measuring the correct information of blood glucose. It's just approximately. You need to what do you call you need to how to say match. Okay, you need to first match with the value from the glucometer from the first device, and after that the device accuracy will be almost similar with the first device. Okay, and for another device, I'm not sure honestly. The another device is like home appliance, smart home appliance. So those device, another device here, I think it's not approved by the medical doctor, because this one is only for life for a very simple purpose. For example, heart rate, blood pressure, and so on. So I'm not sure. I need to check it one by one. Okay, that's it.
Okay, thank you,
You're
Mr.
welcome.
for the answer.
Thank you.
Okay, thank you for the answer, Mr. Kevin and for the answer, Mr. Ganjar. And we will go to the next question, which is Mr. Wimbuh Adi.
Yeah,
Okay, please introduce yourself.
okay. Thank you for the opportunity. Hello, my name is Wimbo. I'm 4 year student of Internet Engineering, Universitas Gajah Mada. Actually, today I have two questions. The first one for Mr. Ganjar and the second one for Department Teddy. Well, for Mr. Ganjar, actually, developing model for machine learning is kind of hard. I've tried it one and I already give up in this step. Is it just the same if I using service like Google AutoML to generate my model, or is it just better off that I'm using already done project like GPT-2 by OpenAI? For the second question, it's for Department 80. Uh, will it be any technology incubator for our college? Because in my opinion, the experience of technological, I'm sorry, I mean, the experience of technology is so broad, and the subject to cover by one major is almost like impossible. Like most of people are excel in certain area but can cover everything. Secondly, development process is so costly, especially for technology. Will it be any incentive from our department? Because the aim of solving problem by leveraging the advancement of technology, it's kind of difficult to fulfill with certain setup. Thank you.
Okay, thank you for the question, Mr. Wimbu. And Mr. Gajer, could you answer the first questions?
Right. Thank you very much. Question from Mr. Wimbo Aki. It's very interesting. Actually it's what you can say. Uh, it's actually it's already faced. It's faced by everyone. Okay, not only by the student but it also for the research community. Uh, the question is that is it same? For example, with the result, for example, if we develop machine learning algorithm, is the result will be same with the well-known service. Nowadays, for example, it is already provided by Google and OpenAI and so on. So the answer is depend on your case and depend on your purpose. Okay, my purpose here is for research, which means when in research we cannot just only well-known algorithm. We need to try to improve the recent technology. So that's why for the research it is better for us to build from the scratch because we will give some additional feature there. The unique thing. If we're talking about study for PhD, S3, okay, PhD, it is very important to find the unique thing when we try to develop this type of algorithm. Okay, we cannot just right away using well existing service. But if your purpose is for deployment for the project for the real time application, yeah, you can use it. You can use the well-known this well-known service, and it can provide you the fast result and you don't need to do very complicated way. It will give you right away the answer, and maybe you just pay some service. Maybe if your problem is simple enough, then you can use the well-known service. You can use well-developed service, and maybe it can solve your problem. But if imagine you have very complex problem where nowadays there is no service that can help you. So as a solution, you have to develop from the scratch, right? So yeah, my answer is depend on your case study. Okay, it's depend on your purpose. If you do research, for example, like in PhD or researcher, peneliti, S3, you need to develop from the scratch. But if your purpose is for project development, then yeah, you can write away using existing service. Why not? I hope the first answer satisfy your question. For second one, I will give to Mr. Elanga.
Okay, thank you. Do you still have more questions, Mr. Wimbu?
No, I'm done.
Okay. Then for the second questions is for the Department of TEDI. Is Mr. Rahman Rashid available? Yes, hello, Mr. Okay.
Sorry, I'm not follow internally about this. So, can you repeat the question about from for Teddy, please?
The question was about will Sekolah Vokasi UGM providing or initialize technology incubator program? Because in Wimbu the opinions, the technology is really broad to cover.
Yeah. Okay. I think. Yeah. I think we can. We have the many lecture for the research group, right? So I think we can derive from that group research, and we can empowering the student to have to collaborate in this research, especially for the maybe for the topics this, right? So I think it's a good feedback from people to our department. So I think we will note this feedback and will I will give the more to form. So I think that's answer. So we can I can we give back to your to the moderator.
Okay. Okay, thank you for the answers, Mr. Norman Roset. And
Thank you very much.
Thank you, sir.
is there any more questions? Please chat first, and then we will give you the opportunity to ask. Okay, we have another questioners, which is from Miss Miss Nur Ardia. Okay. Hello.
Yeah, hello.
Yes, please introduce yourself.
Good afternoon, sir. My name is Noradia from Software Engineering di Jemada University. I want to ask you about what kind of good and effective approach to introduce about IoT to the public. Because, as we know, IoT has become a part of life for people who live in smart cities like Yogyakarta. But in Indonesia, there are many cities and people who haven't been educated to use technology in their daily lives because it is in accordance to culture and habits in some city or area. Thank you.
Okay, thank you for the question, Miss Nur Ardia. Would you like to answer the questions now, Mr. Ganjar?
Yeah, okay. The question from Miss Nur Ardia is that what kind of approach that to introduce the IoT in public, especially in Indonesia, where we have very different case. We have problem of infrastructure, IT infrastructure, where the place which is in the remote island, for example, it is still not covered by the internet yet, for example. So yeah, it is very difficult, difficult solution in my opinion, because it is different. For example, we here in South Korea, almost every part is covered by internet technology, internet connection, where if we implement any technology, it will be very easy. But we cannot just do it right away. Same scenario in Korea and then just do it in Indonesia. We have to see the problem in Indonesia, and also we cannot just forcing people to use the IoT technology. We have to evaluate what kind of first technology that we need to do it in urgent in short time. For example, of course, if we try, for example, if we try to implement IoT or machine learning, maybe in factory, it's still not efficient in Indonesia, right? Because we have still so many problems with automation. Okay, for example, we are talking about problem. For example, in Korea, the ID, personal ID, like KTP, seperti KTP, everything is connected. Okay, it's what you can say. It is centered. The data is centered, and almost every institution, government institution, they can access the data and everything easily. But we still have problem with those with the situation, right? So I think we cannot force. My answer is that we cannot force implementation of IoT in Indonesia. Okay, we need to see first what is the most important problem that we have to handle. Okay, and after that, maybe just automation, small automation, make it everything store. For example, like KTP and so on. Maybe that we have to do it first. Okay, before we talking about another smart device and so on. Maybe in the big city, yeah, I agree with the questioner. In some big city we can do it, but in the small island where we don't have internet connection, yeah, we cannot do that. Right? So we need to see and we have to evaluate. I think that's my answer. I hope, yeah, give some good insight. Thank you.
Okay, thank you for the answer. Okay, the next following question is with Mr. Rofik. Okay, Mr. Rofik, could you please introduce yourself?
Thank you very much, Mr. Elangga, moderator. Mr. Ganjar Satiawan, I'm a lecturer in Electrical Engineering Information Department, and I'm very happy to hear your lecture this morning in Indonesia. In my opinion, nowadays developing the IoT devices is like a racing, and this happens in every country. Do you think in Indonesia we still have a lot of things can be IoT, IoTs, and which has not been developed in any other country? Thank you very much.
Right. Okay. I'll try to answer right away. From Mr. Arofik, Muhammad Arofik, do you think that we can compete with another country in terms of developing the IoT and implementing the IoT in an application? So yeah, it's very tricky question. Almost similar with the previous one. We cannot just do it right away. Similar scenario in different country and then just apply it with our country. Again, we have to see what is the unique thing in Indonesia, and we have to evaluate what type of service that maybe cannot be applied in different countries. We have in Indonesia we have farming, and also we have a lot of sea and sailor. Maybe we can apply this type of energy, this type of IoT in that area. Okay, maybe in terms of manufacturing, we are still far away behind. The rest of our country, for example, Japan, Korea, China. I think we cannot compete in that area, right? So we need to find what is the strongest point in Indonesia. I believe we have for farming, we have a huge sea. I think, yeah, maybe we can explore in that area. Yeah, I hope my answer is good.
Thank you very much, Mr. Ganjar.
Welcome, sir.
Okay, is there any more questions? Is there any more questions? Okay, if there are no questions, probably may I ask also to you, Mr. Ganjar?
I hope it's not the difficult question.
No. It's about on page 34, I think.
34. Okay, let me see. I think 34 is this one.
Oh, sorry, 33.
33, yeah.
Or which one that has the XG boost? Sorry.
Oh,
yeah, that one. Yeah.
this one, yeah.
Okay. I have a question about the XG boost. As far as I know, XG boost is one of the ensemble learning, right? Yeah, and in the on ensemble learning, one of its disadvantage is when it is performed on real time predictions. When I see that you also apply XG boost on the when predicting the blood sugar of the patients. My question: how long does it take for this XG boost to be performed? Is it quite? How long does it take? Because I was just thinking that inside I read from one of the article that ensemble learning disadvantage is the the performance. I mean, the time of the creation of the training
The
stuff.
time computation, yeah, right,
Yes.
right. Thank you. Question from Mr. Ailanga. Yeah, I do agree with this performance of HG Plus. Time computation, yeah. You mean if we compare, for example, with another algorithm, for example, black box type or neural network, multilinear perceptron, yeah, it's quite faster actually because the concept of this ensemble learning is they utilize small decision tree, right? Small decision tree model, and they do the voting. Okay, it's a little bit different as compared to random forest because in XGBoost we when we develop the new model we learn from the previous model. But anyway, we use the small decision tree, and decision tree itself is quite fast for making for doing the learning and prediction, and yeah, it's quite fast. It's depend on the computer also. Okay, but if you compare with the type of image processing algorithm, for example, CNN, yeah, the XGBoost is very fast because in image we will take time to learn, and CNN is very deep, and yeah, it will take time for the CNN. But XGBoost, yeah, I do agree, it's very fast. It can give the prediction right away. If we use, for example, in my case, we do implementation in Python, and for example, we how to say, we save the model using job if, for example. Yeah, if we have a new data, it can give right away the prediction. The problem is maybe if you have so many data access together at the same time. I didn't try it yet. Okay, so thank you.
Uh, Sorry, I have another questions,
Yeah.
which is in this page on 36 page, I see
Yeah.
that the training and testing is 50-50. How do you come up with the 50 and 50? Because most of the paper, I mean that I read that the most optimum is around 70-30. Probably you can tell us what is the background why you choose 50-50.
Yeah, right. I mean, it's depend on the cases. I think, yeah, if we have more size for training, it will give the highest prediction because the model will learn.
For the attendants which already follow these webinar sessions. And this is the first part of the webinar session. See you again in the next sessions.
Thank you.
Thank you very much.
Thank you, sir.
Mr. Ono?
Yeah.
Yes. The the session is yours now. I will give it back to you.
Oke. Terima kasih Mas Erlangga ya sama Pak Ganjar.
Ya, terima kasih Pak Erlangga, Pak Ganjar.
Sama-sama Pak. Semoga bermanfaat.
Ya,
Hari kita belum sempat sesi foto bersama tapi sudah keluar tadi.
tadi saya lepas masuk.
Kelas ya Pak. Masuk kelas ya Pak.
Iya, ini saya tadi ambil kuliah tadi, Pak.